Hello, my name is Thomas Rodriguez, and this is my Lab 1 for Physics 2212. So to introduce this lab, the purpose was to demonstrate how electric interactions affect the charge of tape. For the fundamental physics principles I used, the first was Coulomb's law, which is the formula for electric force, and it's that electric force is equal to the constant times Q1 or Q2, so first charge, second charge, over the distance between the two charges squared times the direction of the distance between the two charges. And gravitational force, G equals 9.81 meters per second squared, and it's the force of gravity that on an object that is constant and acts downward. And then there's Newton's second law, force equals mass times acceleration, where if you have the force acted upon an object and the object's mass, you can solve for its acceleration if the mass is constant. The model that I used for this experiment was a free body diagram, and the main result was that ripping a tape on top of another piece of tape would remove electrons, and that the two charged pieces of tapes, also called U-tapes, would repel each other because they have the same charge. For an overview of the lab, some assumptions was that I would ignore air resistance and that the object would have a constant mass and that the electrons would be spread uniformly along the tape. And some initial conditions was that the charge of a proton would be 1.6 times 10 to the negative 19th coulombs. The length of an atom is 1 times 10 to the negative 10th meters, and that gravity is 9.81 meters per second squared. And for the system was that it was the tape that was going to be floating, and the surroundings was the tape attached to both eraser blocks, as well as electric forces and gravity. So for the details of the experiment, step 1 was to charge two pieces of tape by ripping it on top of this base tape, as shown here. Step 2 was to place one of the U-tapes between two eraser blocks, and step 3 was to hover the second U-tape under the first one and measure the separation distance, because over here, since they're charged and they have the same charge, they would repel each other, and then we would be able to measure that separation distance using a ruler. And then questions for the experiment. So what is the length of one of the pieces of tape? We measured it before the experiment to be 0.2 meters. And what is the mass of one of the pieces of tape? We estimated that it would be 2 times 10 to the negative 4th kilograms. As for the separation distance that we measured in step 3, we measured that to be 0.0254 meters. And for the magnitude of the gravitational force on the floating piece of tape, we calculated it using mass times gravity, with the mass that we solved in this question too, times gravity, to get 0.001962 newtons. And then for the magnitude of the electric force, we used the gravitational force and set it equal to the Coulomb's law, and then we plugged in K and the separation distance to solve for Q, and then we were able to get Q. Also note that Q1 and Q2 are both the same charge, which is why you can just do Q squared. And then after that, we find electric force by once again plugging in the values, but with Q equaling the Q in step 1, and again using the separation distance, and we were able to calculate 1.96 times 10 to the negative 3 newtons. And for the calculated data, so this is the code, as you can see here with all the steps. And then this is the free body diagram. So yeah, you can see the initial constants here. You can see solving for gravitational force, and then a function for electric field, and then solving for the electric force. And then the magnitude of the charge of the tape was 1.18 times 10 to the negative 8. And then some assumptions I made were that I would ignore air resistance on a moving object. I would assume that the tape is a point charge, and assume that each tape had the same amount of charge being evenly distributed along the length of the tape. And for the conclusion, some possible errors was that friction and air resistance probably played a part in the experiment, and that the electrons on the tape are not evenly distributed. And then for the what if question, what if electrons had positive charge and protons had negative charge? What would change about the observations we made in the lab? Well, I believe that the observations would stay the same, and that the two U-tapes would still repel, because that even if the electrons and protons switch charges. Due to how the experiment was set up, both tapes would still have the same charge and would still therefore repel. And then for what does the mean question, it's important to handle the charged tapes as little as possible. What would happen if they came in contact with your hands? Well, the electrons would go to the electrons from your hand would go to the pieces of tape, making it less negative, or making it less charged. And that concludes this lab.